Hello student, welcome to our channel Math with GG. Today's topic is curve tracing. Before starting with the today's topic, if you have not subscribed our channel, please subscribe for the upcoming videos and the content we shared on the channel. Let's start with today's topic, curve tracing. In today's topic, we are going to learn the curve tracing of type 1 curves, that is Cartesian curves. To trace the Cartesian curve, we have 5 rules. The rules are, first rule is symmetry. In this rule, we will get the nature of the curve, whether the curve is symmetric about which line or which quadrant or which axis. This gives us by the rule number 1. Rule 2, the point of intersection. Curve cuts whether x-axis, y-axis, passing through origin or any other point where curve cuts x-axis or y-axis. Third, asymptote. Asymptote means the tangents at infinity. Rule number 4, special points. Now in special points, we have two types of points, cusp, node, and the last is the region of abscess. So these 5 rules, if we explain thoroughly, we can able to trace the Cartesian curves in a very easy manner. So let's start with the first example of Cartesian curves. The question number 1 is, trace the curve xy square equal to a square into a minus x. If you observe, the curve is expressed in the terms x and y. The powers of x and y are natural numbers. Hence, we can trace this curve using the Cartesian curve rules. The first rule is symmetry. For symmetry, we will first check the degrees of x and y. Now, if you observe in this example, there is only one term of y and the degree of y term is even and degree of x term is odd. Hence, if the degree of terms in x, each term in x is even, curve is symmetric about y-axis. If the degree of each term in y even, curve is symmetric about x-axis. So clearly, if you observe, the degree of y is even, therefore the curve is symmetric about x-axis. So let's start with the first rule. Rule number 1, symmetry. As degree of each term in y is even, therefore curve is symmetric about x-axis. So in rule number 1, we have discussed about the symmetry. Now the rule number 2, points of intersection. In this rule, we will first check whether the curve passes through origin or not. For that, we will first express y as a function of x or x as a function of y if possible. Now if you look at the example, we can clearly express y as a function of x. Explicitly we can express y as function of x. So as y square equal to a square into a minus x divided by x. Now if you replace x equal to 0, the denominator will be 0. Hence y cannot be 0. So curve do not passes through origin. So the first point, origin. For x equal to 0, y not equal to 0, therefore curve do not pass through origin. If we get for x equal to 0, y equal to 0 or vice versa, for y equal to 0, x equal to 0, curve passes through origin. That in short, 0, 0 should satisfy this equation. But in this problem, 0, 0 does not satisfy the equation. The second rule is usually, if the curve passes through origin, we will find out the tangent at origin. But as the curve do not pass through origin, we will skip the tangent point. Then we will go to the next part, that is whether curve cuts x-axis or y-axis. Now if you observe the term a minus x, clearly if we put x equal to a, y equal to 0. So for x equal to a, y equal to 0. If you put a here, a minus a 0, therefore y equal to 0. Therefore, curve passes through a comma 0. That means curve cuts x-axis at the point a comma 0. This is rule number 2, points of intersection. In this, we have studied 2 points, whether the curve passes through origin and if there is any other point where curve cuts x-axis or y-axis, and we get curve passes through a comma 0. Now, we have to study rule number 3, asymptote. Before we start with asymptote, what do you mean by asymptote? There are 3 types of asymptote. One is asymptote parallel to x-axis, asymptote parallel to y-axis, and oblique asymptote. Now, in this example, we are going to learn the asymptote parallel to coordinate axis, that is either x-axis or y-axis. So, let's start with the rule number 3, asymptote. Let's start with the rule number 3, asymptote. For asymptote, what we will do, we will first express either y as function of x or x as function of y. As studied in rule number 2, we have already expressed y as function of x. So let's rewrite the term. So y square equal to a square into a minus x upon x. Now we try to find the value of x for which the denominator is 0. If you observe, if you substitute x equal to 0, the denominator is 0 clearly. In short, if we consider as x tends to 0, this y tends to infinity. To find the vertical asymptote, we will get a number a such that for x tending to a, y should tends to infinity. In that case, x equal to a is your vertical asymptote. For this example, as x tends to 0, y is tending to infinity. Therefore, x equal to 0 is vertical asymptote. X equal to 0 is vertical asymptote. Now, next rule is spatial point. To find the spatial points, we'll go to rule number 2 first. If you observe, curve is passing through a comma 0. Now let's study how many branches of curve we are having. If you observe the degree of the term a minus x, it is clearly 1. Hence, the point a comma 0 appears only once. So, curve do not have any spatial point. For example, suppose there is degree of this bracket is 2. That means a will appear 2 times. 0 is also appearing 2 times. In that case, a comma 0 will be double point. But for this example, if you observe a minus x, the degree is 1. Hence, a comma 0 is appearing only once. Therefore, the curve do not contains any spatial point. So, curve do not contains any spatial points. Rule number 5. A region of absence. To find the region of absence, if possible, we'll find out y in terms of x and we'll try to find the value where y does not exist. So if you observe, y square is equal to a square into a minus x. If we take the square root on both sides, we get y is equal to a under root a minus x divided by x. Now for this term, if you observe, there is a term of square root. Now we know that square root of negative number does not exist. So we are interested in finding the values of x so that this ratio will be negative. Now the ratio is negative if either numerator is positive, denominator is negative, or denominator is positive, numerator is negative. Now if you observe, suppose we consider denominator is negative, that is x less than 0. So if you consider for x less than 0, now if you observe numerator is a minus x, x is negative number and we are subtracting it from a, therefore the term a minus x will be positive, hence the ratio will be negative. As this is positive, X is negative, ratio is negative. Therefore, y does not exist, or in other words, y will be imaginary as square root of negative number does not exist. For x less than 0, y is imaginary. Therefore, no part of curve lies to, as less is there, left of x equal to 0. Now, earlier we have considered x less than 0, that is denominator. Now we'll consider numerator as negative. If we consider a minus x is negative, that means a is less than x, that means x is greater than a. So let's start with for x greater than a. If you observe, a minus is negative, a itself a positive number, therefore as x is greater than a, therefore x will be positive. So numerator negative, denominator positive, ratio negative, hence y will be imaginary. Therefore no part of curve lies to the right of x equal to a. Hence, curve does not exist for the left part of x equal to 0 and right part of x equal to a. This is the 5 rules of curve tracing. Now, we'll draw a rough sketch of the curve given in example number 1 based on these rules. Now, let's draw a rough sketch of the given curve. To draw the rough sketch, we'll first go to the last point, region of absence. If you observe, for x less than 0, curve remains unchanged, curve remains absent. For x greater than a, curve remains absent. So, if we draw a point a comma 0 here, so your curve will lie between these two parts only. As for x less than 0, curve is absent. For x greater than a, curve is absent. So curve will remain here. Now, if you coming back to the point number 2, curve passes through a comma 0. Is it special point? No, curve is not having a special point. Coming to rule number 3, x equal to 0 is your asymptote. So x equal to 0 means y-axis. So this is x equal to 0 is your asymptote. Asymptote means the curve will cut or touch this axis at infinite point. That means curve will come close to y, but it will not touch y-axis either on both sides. So if we, based on this, as the curve is symmetric about x-axis, we'll draw the part in first and that will be symmetric as in the second. Curve passes through a comma 0 as y-axis is your vertical asymptote. Therefore, the rough sketch of the curve will be like this. As it is symmetric, the curve will be as per the given diagram. So, this is example number 1 for curve tracing of Cartesian curve. We have studied one example of Cartesian curve of type 1. In the next video, we are going to learn the second example of the same type of Cartesian curve. Make sure that you should subscribe our channel so that you will get the notification once we upload the video of part 2.